All right. So this problem is a little tricky. It's not something that I would expect a whole bunch of 7th graders or 8th graders perhaps to see, but it's not difficult. And I'm willing to bet you'd be able to do it just by using those powerful brains on top of your shoulders. So here's what's happening. You have a pair of parallel lines. One here called U. This one is V. And so this is line segment UV. And it is parallel to line segment RS. And to show that they are parallel, in mathematics we have a symbol for parallel. And that symbol is this little line, these little arrows that you see on your paper. That means the lines are parallel. That notation is used the world around. So every time you see it, you know it means parallel lines. Then we have something called a transversal. A transversal is nothing more than a line that crosses your parallel lines. That's all it means. Now, when you have a transversal, there are some key ideas in geometry that you have to know. And so I'm going to use some vocabulary here that would be expected of you in this problem. So I'm going to write it out. I want you to write it out. If you remember it, that's going to really help you when you get to geometry. We know that alternate Braden?
Interior. I don't remember the rest.
Angles.
Oh, I got it.
Is that angels? Whatever. Are
Congruent.
congruent.
Yeah.
Is it E or A?
It's E. It's E.
Okay. I'm hooked on phonics. All right. So alternate interior angles are congruent. Here's what that means. Alternate, that means on the opposite side, right? Alternate, that's the opposite side. Interior, that means inside the parallel lines. Angles, well, we all know what an angle is congruent. So let's take a look at this. So what does that mean? Well, let's take a look at this. Alternate, well, what is the alternate to this angle?
S.
It's not angle S. It is angle TSR. Remembering that the vertex has to be in the middle. So I could have said RST as long as that vertex is in the middle of my letters, okay? So these are alternate angles, and they are inside the parallel lines. Therefore, they are congruent. To show congruent angles, we have this little arc with a line through it. That means these angles are congruent. That's just what it means. But wait a second. We have a second transversal. And the second transversal will create more alternate interior angles, and they're congruent. So what is the alternate interior angle for this one? TRS. But wait a second. If I put one line through the angle, that means it's congruent to these two as well. Is that true?
Yes.
No. No, it's not. So I need two lines. So now I know that this line is that angle is congruent to that angle because of those two lines. And this angle is congruent to this angle because of the single line. Now we have a second thing that Eli, we're going to talk about. Are you ready? Okay. I know this is like the most exciting thing you've ever seen in your life. Vertical angles are what is a vertical angle? That's a rhetorical question. A vertical angle is going to be angles that are across from each other like this. And well, if I put one line in the middle, it means they're all, so I need to put 3 lines. Wait a second. Spoiler alert. Before I even look at the problem, just by reading what is on the text, I see I have 2 triangles, and both triangles have congruent angles. Therefore, these triangles are similar. That means they're similar because, you'll remember that similar figures have the same angle measurements. Now you see why this is showing up in 7th grade, even though this stuff, anyways. So, let's look at the problem. The problem says, explain why triangles RTS is similar to triangle VTU. Oh, well, why are they similar? They have the same angles. And they have the same angles because, and this is your explanation, because alternate interior angles are congruent and vertical angles are congruent. That's it. The last problem, I'll take your question in a second. Your last problem says that the measure of STV is 108. Okay, well, let's think about this for a second. What's the measure of this angle here? Oh, okay, so therefore this angle must be? 72. What is the measure of all of the interior angles in the triangle? 180. 180. Oh, so what does that mean about the sum of those 2 angles? They have to equal 108. Oh, that's kind of funny, isn't it? Yeah. Huh. That's it.